For my business, I operate two 3D printers in my office a lot of the time, and I was interested in how much pollution they generate that I have to breathe in, specifically particulates between 1 and 10 microns, which are known to be a significant health risk. I also live in a flat which overlooks a busy main road, and I was interested in pollution from that aspect as well. So I had a little look online to see what was available. At the lower end of the market are devices like this, handheld instantaneous readings, a couple of different channels for particle sizes. If you pay a bit more, you may get a particle counter that combines other atmospheric analyzers in a single unit. And top of the line models, costing silly money, offer lots of different storage and data logging options. Fascinating stuff. So then I started thinking, well, how do they work? What kind of a sensor do they have in them? And the short answer is one of these. This is a PMS 7003, and it's one of a class of sensors which comprise a reflective chamber through which air is drawn and into which light is injected, and scattered light from particles inside the airstream are detected by a detector. Variations on this theme are available all over eBay, and they're not very expensive. They're also not difficult to use. You supply power and you read the serial port, and with no other configuration at all, it will simply dump the values of the three sizes of particles it can detect, that's 1 micron, 2.5 and 10 microns, out through the serial port about once a second with no other intervention. All you have to do is hoover those up. So you could plug this into the serial port of PuTTY or the Arduino monitor, and you'd be reading particulates right there. If you want something portable, you can rapidly power an Arduino with a power pack and lash up a display like this one, and you'll be in the business of reading things. This is sitting in a fruit container, so it's mobile. This simple arrangement just sat on my desk, was able to give me the answers I needed about 3D printing, and more on those a bit later. But with my Fusion 360 skills and my 3D printers, I wanted to try and make something a bit more professionally productized, and I wondered about whether or not I could make a saleable product. Well, I've found the Fusion 360 learning curve somewhat treacherous, and I hit upon something of a brick wall designing this product. It's that error in the bottom right hand of the screen. Now, I had huge amounts of trouble with this and was quite active in the Autodesk forums, and got quite a lot of attention, not all of it positive, but I did get two conference calls with Fusion 360 folks, one of which included some fairly senior managers, and they were incredibly polite and patient and caring about my experiences, and wanted to understand why I was so fed up. So I made a series of videos to illustrate the reality of trying to learn Fusion 360. And unfortunately, those are the videos which I made public by mistake, so I'm sorry to have bothered you with those. But anyway, suffice it to say, if you've had trouble with Fusion 360 learning it, I would love to know about that in the comments below. Anyway, I modelled all of the elements. This is the processor, correctly dimensioned but approximate in other ways. This is the display board with the correct mounting holes and thickness. And this is the battery shield, which is a convenient unit. It takes an 18650 lithium ion cell. It provides USB out at 5 volts, USB in, and a switch, and it provides all kinds of protections for the battery. This little sub-assembly is for the two switches used to navigate the user interface. This obviously is one half of the case with all the cutouts and the mounting studs. Quite a lot of work in that. And of course the idea is that we can assemble all of the components inside the case as they would appear on the real thing, and then close the case and check that everything looks okay and all the holes line up as they should do. Well, anyone that 3D prints knows that things don't go as you expect, and you have to do test prints. So here's a little test print, primarily to check the rebates of the two mating halves of the case, and they seem to be okay. But look at the way one half of the case is far better finish than the other one. The thin part is pretty good, the thick part is dreadful. Don't know why. And here's another little printing anomaly, this periodic paucity of filament starvation causing this striation pattern on the surface. Anyone's got any ideas about what causes that? I'm interested. Let me know in the comments. Anyway, being Mr. 70%, I wasn't really interested in solving those problems, so I just lashed it together with masking tape, as you can see here, for a masterly perfect finish. But it does mean I've got a portable unit, proof of concept, see how it works, see how it handles. It's an effective prototype, but it ain't pretty. So here's how it currently works. There's your basic display showing the three sizes of particle pollution, and there's a backlight you can turn on and off. And you can cycle through a bunch of settings. That left button is binding a little bit. But you can change the contrast, which is one of the areas that's implemented, and you can see that happening there. 50 is about the right answer. So you can select that, move on. I'll implement a battery alarm, an automatic off feature, beep when the keys are pressed or not, and an online system to do data logging and alarms through the internet, and an auditory alarm which tells you when pollution gets above a certain threshold. So let's see it in use. Background levels there, pretty normal. Anything below 12 is considered a good lifetime average. We'll just set fire to a piece of paper, waft it around, and that's a good way of generating particulates, and you can see the numbers go pretty high, pretty fast. Not instantaneous, because there's an air movement delay, but pretty emphatic really there. All is not well in the atmosphere in my office. And I should add, that's nothing to do with my digestive tract. And you can see levels gradually returning to normal. Here's a little traffic test in Bedford. It's diesels which are the major culprit where particulate pollution is concerned. That bus has just gone by and the pollution went up momentarily. It's a fairly windy day. You normally see a much bigger effect, but the wind is carrying it away in this case. This is one of the big surprises from owning this meter. This is more than 2 hours after I cooked dinner, and I wasn't aware of anything, but this is caused by particulates from the cooking process. Well, here's the money shot, I guess. Does my printer, printing PLA at 200 degrees centigrade, pollute my office environment? And the answer is no. Of course, zero readings are always a little bit suspicious, so let's make sure the thing's working. Which it certainly is. I took the temperature up to, I think, 240 or 250 to see if that would increase pollutants, and it didn't do so. So I broke out the big guns and tried some ABS, which I've never printed with before. Bed at 60 because it's magnetic and I don't want to damage that. And the head is at 240, I think. It didn't stick worth a damn on this, but I don't really care. I don't want the print, it's just a test. Well, it's different. It's not very high, but it's there. It was bouncing around 0 before. Now it's sliding between 2 and 7, somewhere around there. Okay, so it's easy to obtain one of these laser sensors for detecting particulate pollutions in the air. It's also easy to read its serial output to get the readings of what the pollution is. If you can claw your way up the Fusion 360 learning curve, you can design yourself a nice case and 3D print it. And I used that to verify that neither of my 3D printers is going to kill me anytime soon, and neither is the traffic outside my office. In fact, the biggest danger I face at home is my own cooking. And the message there is, whether you can smell anything or not, open 2 sets of windows when you've been cooking, and that will clear out the particulates you're not aware of, which would otherwise persist until the morning. So not good for you. Well, that about wraps it up. As always, I'm very interested in your comments. I'd love to know you exist. I can see the numbers, but very few people actually talk to me. which is a big shame. Specifically on this one, when I implement the online features, because it's an ESP8266 in there, which can do all the online stuff, it could upload stats and all sorts of things, send email alerts. What do you think would be a good idea to put in there? What features would be useful? And also, would you buy one? How much would you pay for one? How would you like to see the design altered and that kind of thing? Let me know in the comments below. If you're not subscribed, please do so if you want to see more like this. And thanks for watching.